Hi viewers, in this video we are going to learn about what is an IP address and its versions, classes of IP address and types of addressing. First, IP address and its versions. An IP address is a logical numeric address that assigned to each device. It is used to identify each node in a network. An IP address is a 32-bit numeric address which are separated by dot. So here you can see the example of an IP address. IP address has two versions, one is Ipv4 and another is Ipv6. Now we will see what is Ipv4 and Ipv6 and their header formats. Ipv4, it is a connectionless protocol and it is first major version of IP. It uses 32-bit IP address. Now we will know each field in the header. The first is a version. It is a 4-bit field that says about IP version. It contains the decimal value 4. Next, header length. It is a 4-bit field that is a length of IP header. The actual data starts from the header part. Type of service. It carries information to provide quality of service features. Now, this field is known as differentiated services code point. This field is used by new technologies that require real-time data streaming. For example, VoIP calls. Total length. It is a 16-bit field that defines entire datagram size, which includes header and data in bytes. Datagrams are fragmented due to size restrictions, so it is handled either at host or packet switch in Ipv4. Identification. This field is used to identify fragments of an original IP datagram uniquely. It is also used for adding packet tracing information to datagrams to help trace back datagrams with spoofed source addresses. Flags. It controls or identifies fragments. It is a 3-bit field where bit 0 is reserved and must be 0. Bit 1 is don't fragment, that is DF, and bit 2 is more fragment, that is MF. Don't fragment. Don't fragment bit is a set in sent packets. When DF flag is set for IP datagram, then fragmenting it should not be done by intermediate devices. The datagram will be dropped if it needs to travel over a network with maximum transmission unit smaller the datagram length. More fragments. This bit sets in send packets and tells receiver that current datagram is a fragment of a larger datagram. When it is set to 0, it may be a last fragment in current datagram or it is the only fragment. The next one is Fragment Offset. It is a 13-bit size field. It tells offset of a specific fragment, that is beginning of original unfragmented IP datagram. The first datagram offset is 0. The maximum offset size is 65,528 bytes and can exceed maximum 65,528 bytes IP packet length that includes IP header. TTL, time to live. It is a 8-bit size field. TTL indicates, like in the internet system, what is the maximum time a datagram is allowed. The datagram will be destroyed if this field value is 0. The TTL for processing a datagram must be decreased by at least 1, even if datagram processing is less than 1 second. Protocol. It defines the protocol of IP datagram used in data portion. Header checksum. This field is of 16-bit size that used for error checking of header. The header checksum should be compared with value of its field at every hop. If it finds any mismatch, then packet will be discarded. By encapsulated protocol and UDP, TCP, the errors will be handled in data field. Source address. In sent packets, we can specify custom IP address, that is source IP address. So we can spoof the sender. An Ipv4 address or a host name will be in this address. Destination address. This receiver of packet is indicated by IPv4 address. By network address translation device, the transit may be changed with source address. Options. This field is used to record route, source routing, and padding. The destination address fields are followed by additional address field but are not used regularly. To hold all the options, IHL Internet Header Length field value should have extra 32-bit words with end of list options. The list of options terminates if end of the options doesn't coincide with end of header. This field length is variable. Data. In packet checksum, the data portion of packet is not included. Based on protocol header field value, the contents are interpreted. The common protocols for data portion are ICMP, TCP, UDP, SCTP, etc. Next is IPv6. It uses 128-bit IP address. In DNS, host address resource records are used for mapping host names to IPv6 address. IPv6 extension headers can be an arbitrary length. There are no options and checksums in IPv6 datagram. Now we will look into each field in detail. Version. It is of 4-bit size. This field tells the version of IP, that is 6. Traffic class. This field is 8 bits of size. This field is similar to type of service field in IPv4. This field indicates the class and priority of IPv6 packets. Flow label. The size of this field is 20 bits. This field supports real-time delivery of datagram and quality of service. The purpose of this field is to say that a packet belongs to a particular sequence of packet that travel from source to destination and also prioritizes delivery of packets for services. Next is payload length. This field is of 16-bit size that says the length of IPv6 payload, which includes extension headers and upper layer protocol data. Next header. This field size is 8 bits. If there is availability of extension headers, it tells the type of first extension or the protocols like TCP, UDP or ICMPv6 in the upper layer. Hop limit. It is of 8-bit size that is similar to time to live in IPv4 header. When IPv6 packet travels, this field tells through how many maximum number of routers it can travel. Source address. This field is of size 128 bits. It shows source packet address of IPv6 address. Destination address. This field is of size 128 bits. It shows destination packet address of IPv6 address. The next one is classes of IP address. There are two types of addressing. One is classful, another is classless. In classful addressing, the IP address is divided into network ID and host ID. There are 5 classes. They are Class A, Class B, Class C, Class D, and Class E. For example, the first octet in Class A is called as network ID and the last 3 octets are host IDs. Class A, Class B, and Class C are used frequently, and Class D is used for multicasting, and Class E is reserved, that currently not in use. Classless addressing is also known as CIDR, Classless Interdomain Routing. In this, there is no boundary on network ID and host ID. Types of addressing. There are 4 different types of addressing. They are unicast, multicast, anycast, and broadcast. Unicast. It is a single interface address that uses one-to-one communication. It directly delivers the packets to specific host. Multicast. It uses one-to-many communication where there will be a single sender and multiple receivers. The best example is sending email message to mailing list, video conferencing, etc. It sends single message to group of destinations. Anycast. It sends messages to group of destinations that has same destination address. The last is broadcast. It uses one-to-all communication. It sends data to all possible destinations within a network, for example, television, radio, etc. So, this is about the IP address and its versions, classes, and types of addressing. So, thank you. We'll see you in the next video.
For more videos, please download our application Cyber Future Tech from Google Play Store.